Hello, today we are going to talk about problems involving trigonometric substitutions. These are the problems where you want to solve an integral where the integral has terms something like square root of a squared minus x squared, or the square root of x squared plus a squared, or the square root of x squared minus a squared. Right? The motivation for all these type of problems comes from the Pythagorean theorem. In terms of angle theta, the Pythagorean theorem is written as sine square theta plus cosine square theta is equal to 1. If you divide this equation by cosine square theta, divide by cosine square theta, you get tan square theta plus 1 is equal to secant square theta. So essentially we are going to use only these two type of identities in order to come up with a suitable substitution for these type of problems. This identity, sine square theta plus cosine square theta is equal to 1, you get cosine square theta is equal to 1 minus sine square theta. In this equation, if you multiply throughout by a squared, you get a squared cosine square theta is equal to a squared minus a squared sine square theta. Okay, take the square root, you get a cosine of theta is equal to square root of a squared minus a squared sine square theta. So we have something like this. We have a cosine theta is equal to square root of a squared minus a squared sine square of theta. And the motivation essentially comes from here. So you have something like this. So whenever you have an integrals involving square root of a squared minus x squared, the first thing to consider is put x is equal to a times sine of theta. Okay, if you put this thing as a times sine of theta, you get dx as a times cosine of theta and a squared minus x squared square root becomes just cosine of theta. A times cosine theta. So let us solve a problem involving this term. Suppose the problem is to solve the integral of a squared minus x squared square root from x is equal to 0 to a. Now we can realize that this is in fact in the area enclosed in a circle in the first quadrant. Right? So it is area inside this from 0 to a, and this is y is equal to square root of a squared minus x squared. This is x-axis, this is y-axis. So anyway, so we have to find out this area. Now we know that whenever we have a squared minus x squared, you put x is equal to a times sine of theta. Therefore, dx is equal to a times cosine of theta d theta. Okay, so and then this is a definite integral, so we have to change the limits of integrations. So if x is equal to 0, theta is equal to what? Now for this function, this substitution, we have to choose an interval of theta where this function is a one-to-one function, and one of this interval is from minus pi by 2 to minus pi by 2 to pi by 2. So if we consider this part, this is pi over 2, this is minus pi over 2, we see that this sine of theta is a one-to-one function from minus pi by 2 to pi by 2 closed interval. Okay, so in this interval, if x is equal to 0 and x is sine of theta, so a times sine of theta is equal to 0. This has a unique solution in this case, as theta has to be equal to 0. In the same way, if x is equal to a, what is theta in this case? So if x is equal to a, we have a times sine of theta is equal to a. Sine of theta becomes 1, and in this interval we have sine of theta as 1 only at this point where theta is pi over 2. So this integral, after the substitution x is equal to a times sine of theta, becomes I equal to theta going from 0 to pi over 2, and this becomes a times cosine of theta, and if x is equal to a times sine of theta, dx becomes a times cosine of theta d theta. So essentially we have this integral to solve, and this is a times a squared comes out, integral 0 to pi over 2 times cosine square theta d theta. Okay, to solve this integral, you use the half angle formula, which says that cosine square is 1 plus cosine of 2 theta divided by 2. Okay, so this is the first integral is a over, this is a squared over 2, integral 0 to pi over 2 of 1, and then the next integral is a squared over 2, integral 0 to pi over 2 cosine of 2 theta d theta. Okay, so the first integral is very easy. This is just theta from 0 to pi over 2. So this will become pi by 2 minus 0. So this is easy. How about the next one? Next one is also easy. So I will do this part here. This thing is the first interval, a square over 2 times theta from 0 to pi over 2 plus a square over 2, integral of cosine of 2 theta becomes half times sine of 2 theta from 0 to pi over 2. So here we used a substitution, u equals 2 theta, and therefore du became 2 times d theta. So we have to divide by 2, and then integral of cosine of u becomes sine of u, but u is 2 theta, right? So if you don't know, you should work this thing out. And then the first one is easy. Here a square over 2 times pi over 2 minus 0 and plus a squared over 4 times sine of 2 theta, sine of 2 times pi by 2, which is sine of pi, minus sine of 0. Okay, so sine of pi and sine of 0 both are 0, so this becomes just 0, and the answer to this our problem is pi a squared over 4. Now remember, our problem was this, which was essentially the area of quarter of a circle. So the area of a circle is 4 times that, which is pi times the radius squared.